Down the basement, I needed some shelves, and I have a leakage problem, so I didn't want any legs down on the floor to get in the way of keeping it clean. So the idea I came up with is to hang the boards off of the floor joist. And in here you wouldn't have enough room to nails, so I drilled holes big enough for nails to fit through, and I used sturdy nails to make sure it would hold the weight. And it's pretty straightforward and simple. Just keep your boards straight up and down and keep them level, and it went pretty quick and easy. Over here on this wall we have a problem. What do we attach the sides of the shelves to? This is something I have to think through. To help us see up in the corner where we can't see, I set out the bricks and ignore the can here. Their cans are just there to provide support. So the way a house is built, you have a brick foundation. This is the wall facing up to the sky. Over your foundation, you have what they call a wood seal, and your floor joists go on top of that wood seal. Here's the other wood joist running from one wall to the other. Just add a little bit. Then across your floor joist you have your floorboards. So this is what's up in the corner. What we need to do, cut a board that will fit inside of here. And as you can see, that board will be jammed in real tight. Then we can start hanging our shelves off of that board. So we need to make some accurate measurements and make a drawing so we can see what we're doing a little better. Had a little bit of problem with our anchor plate to where there's nothing up there to stop it from moving side to side when you try to screw it. So I had to put this little piece of scrap board here running diagonal to hold it in place, and it's just a quick little tip screw there to hold it. And it held it until I could get the sides of the shelf screwed in and made sure it was plumb straight up and down as I did it, and started putting the shelves in. The way you put the shelves in level is you mount the support and using a line level, make sure it's plumb and screw that in place. Then while holding your board on top of that, you get your other support and you draw a line underneath the support. And then you screw that into place. Then you just put your shelf right on top, making sure that it's plumb. Finished! Now I can load it up with the stuff for the garden. In order to get our drawing onto our paper, we need to come up with the scale so it will fit. And I like to use the centimeter scale and just ignore the name and just think of this as a uniform set of evenly spaced marks. And it turns out that 15 will fit perfectly if I use 20 marks to be equal to 1 foot. Now let's create a scale that would help us to interpret our measurements from our drawing. And if we use 20 marks, that's going to be equal to 12 inches. Half of 20 would be 10 marks, would be equal to 6 inches. Half of 10 would be 5 marks, would be equal to 3 inches. In order to get down to our inch accuracy, 2 marks would be equal to 1 inch. The way a mechanical drawing works, you have a T-square which will fit onto a straight edge, and you'll have horizontal lines that'll be parallel to each other, so that adds uniformity. In order to get your vertical lines, you use a triangle, which forms a square, and that will give you your vertical lines, and they'll be parallel to each other also. And in order to get your measurements, you just place your ruler against the triangle, and that'll get you your measurements for your vertical lines. In order to convert our rough drawing onto a drafting drawing, I find it easier if you have two reference lines, a horizontal reference line and a vertical line. I'm going to use the ceiling as the horizontal, and I'm going to use the edge of the brick wall as the vertical. So as we can see, the brick wall is 8 3/4 inch. So this is going to be the mark for my vertical line reference. So I'm going to use that to line it up. And from there it's 8 3/4 inches. Now that's almost 9, so that works out perfect. 10 and 5 marks would be 15. From here we come over 10, 15. And the joist is 2 inches thick, so 2 inches would be 4 marks. We go there and we put a mark there. And then from one joist to the other is 14 inches. And 14 inches is almost 12 inches and 3, which would be 25. So just shy of 25. So we'll come over from the joist mark. So 10, 20, just short of 25, we'll put a mark. Then we have the thickness of the joist, which would be 2 inches. So 1, 2, 3, 4 marks. Now we need to get the vertical reference. So where the wall is that the thickness of the joist is 9.5 inches. And here's 9, and half would be maybe 10. That would be just a little bit more than 15 marks. So coming down, so there's 10, there's just shy of 15. And there's the thickness of the seal, which is 2 inches again. So 1, 2, 3, 4, that's the thickness of the seal. And from there on down is the wall. And we'll line this up because the wall is going to be a total of 150 marks, so we'll just draw it from here on down. And down here at 12, that would be 6 foot. So we have a mark down there for 6 foot for the shelf. Now it's just a matter of connecting horizontal and vertical reference marks, which just makes the drawing simple. So here we have the joist, which comes down. There's the joist, and it comes down to there. So there's joist coming over, joist coming down. And we have the other joist over here, coming down, coming over. That's the joist. That's also where the seal is. Seal is 2 inches thick. Bring this back in. There's the seal plate marked. And the brick wall just comes straight on down from the outside, although it doesn't really reference anything. And I've decided that the thickness of the shelf is going to be 7 inches. So that's from here out 7 inches on our scale. be a little bit more than 10. So there's 10 marks, a little bit more. Put it out just about even with the joist. So we can use our triangle to mark down to the shelf. There, that's the bottom of the shelf. Come up, top of the shelf, and this is going to be our shelf going all the way up. So this is our shelf profile, and now we'll add some dimension lines. Well, I had trouble concentrating. I was making mistakes trying to talk and draw at the same time. So I had to shut it off in order to make my drawing. So here we have the finished drawing. This here hashed area, that's the shelves from the side hanging down. It's 6 foot long from floor to the bottom of the shelf. And it's a, I decided it was going to be a 7.5 inch wide board because it would come out flush to the floor joist. And for the board we need in order to hang the shelves off of, that's going to be 9.5 inches, which is the length of the or the height of the floor joist, and 14 inches from side to side. Now these lines with arrows, those are what they call dimension lines. And that you draw with a straight line and then this ruler up and down in order to get this here, but that's how we've done on our rough hand drawing also. That's a more precise look of what it's actually going to look like when you build it. Here is a second drawing of just the bookcase. And going through the process of making the drawing, we come to realize that for every shelf we add, we're losing 3/4 of an inch for the thickness of the shelf for our available space. And in placing the bookcases, we have little choice. The first shelf is going to be here because of the coal chute. Bottom shelf is required on the bottom to hold it together, a firm unit, make it a firm square. As for the spacing the shelves in between, that's where we need to measure what it is we're going to put on the shelf. And I know that most of my stuff is just going to be garden seeds, flower seeds, annuals that I pull the seeds off at the end of the year and then replant the next year. So I pretty much know what they're going to be. And we realize that the board lengths come in even units of 2 foot. So I know if I buy an 8-foot board, I can cut it in half and have 4 foot in between. And the overall width is going to be 49.5 because each board is 3/4 inch thick on the edges, so that's going to add to the width. These are the things that we think through when we're doing the drawing, because it's like seeing the project before you build it. And that's why I think a mechanical drawing is important in doing any project. To do this project, I went out and I bought a math set. Came with the triangle and the ruler and the compass here, and it was only $2. I have had this T-square for a long time. I could not find a store that sold those, but you can buy those online from a school supply store, and it only costs $2. So if you're willing to get started for $5, you could get yourself started. And as in here, I use a piece of cardboard for my drawing board. That's not what I normally use. Normally I use this wood panel from a garage door that I tore apart. And to be weathered for many years and still be flat and square, I thought that was pretty good. So this is you notice the triangles are a little bit bigger than in the set, and I still use the T-square. And I also use a little bit larger ruler. Now, these aren't always available, but they do come up every now and then at dollar stores and discount stores where you can get you a nice set for under $10. I was lucky when I went to a auction, school auction, where they had a larger set that when I was building a garage that I use. And this is very similar to what I used in my high school drafting class. You have a large T-square. You notice the triangles are even larger so you can cover more area, and also the ruler is a triangle shape, and that really helps to stop from going underneath the edges of your different pieces. And this here is from a desk calendar, and I liked it because I could just slide the paper up underneath and slip it down under the corner tabs, and it would hold it in place. Most times you would have to tape it or find some other way to hold the paper in place. And also you're going to find that computer paper 8x11 limits what you can draw and actually see what you're doing. But if you go to the art supply store or in the art section, your drawing paper is quite a bit bigger. It almost doubles your space for drawing, so you can get more accurate details on bigger projects, or for a smaller project to make it bigger. And you'll find that you can even go substantially larger, and this is what fits in the ink blotter or the desk calendar blotter. So if you want to grow in using your tools, it's very easy. It's out there, it's easily accessible. So you can't be limited in growing in your skills and using drawings to satisfy your needs in working through projects. Hope you enjoy this.